Hi everyone. At the end of this lesson, you will be able to factor a polynomial using the GCF method. You will identify the GCF of all terms and use backwards distributing. Take a look at the do now on your paper. What property is illustrated below? How do we know that 5 times the sum of a plus b is equivalent to 5a plus 5b? Hopefully, you're thinking of the distributive property. Another topic I want to review quickly before we get started is the greatest common factor. Take a moment to list all of the factors of 8, list all of the factors of 20 and 24, and find their greatest common factor. Please pause the video while you show your work. All right, you can see that I have listed my factors of 8. I like to list them in pairs, 1 times 8 and 2 times 4. And then my factors of 20, 1 times 20, 2 times 10, 4 times 5, and the factors of 24, again as pairs. We are looking for their greatest common factor. Remember, factors are a breakdown of a number. Multiples are when you list numbers like 8, 16, 24, 32, and so on. So factors are when you're breaking down the number. Well, it looks like our greatest common factor among all 3 lists here would be 4. So, the greatest factor that these 3 numbers have in common is 4. All right, let's get started with the first lesson in this unit, all about factoring. Factors are expressions that multiply to give you a product. And luckily, there's a calculator trick for this. So let's say you might have had a hard time listing the factors of these numbers, or maybe it's harder when the values are larger. There is a calculator trick that will always help. If you go into y equals and you type in the number that you're trying to factor divided by x, we can cheat and kind of look at the table to get a list of the factors. So let's try this for the number 30. If I go to y equals and I type in the number that I want to factor, which is 30, and then divided by x, and then I go to the table by hitting second graph, it's good that I see this error here for 0, because 30 divided by 0 is impossible, it would be undefined. But here I have the list written as pairs the way I usually record my list. 1 times 30, 2 times 15, 3 is also a factor of 30, goes in 10 times, 4 is not a factor of 30. I know this because it has a decimal. 5 times 6, and now I know I'm done with the list. Once I go in order, so 1, 2, 3, 4, 5, and then if I catch the very next number on the other side of the table, that means we've found all pairs. So now we just have to record the pairs on our paper. Please pause the video and use this trick to record all of the factors of 24. If I change my calculator to say 24 divided by x and go to the table, I will find my list of factors, and then I can record them on my paper. We can also find factors of monomials with variables. Unfortunately, the calculator trick won't help for this. The calculator does not know algebra. So instead, I have to think of ways to break down x squared. The first pair I always list is 1 times, and this should say x squared. So 1 times x squared is the first pair of factors. Next, I would break down x squared by saying x times x is equivalent to x squared. Let's take a look at a cubed times b squared. I first listed 1 times a cubed times b squared, but we could also break it apart as a cubed times b squared. If we really wanted to, we could break it apart even further. A times a times a times b is also equivalent to a cubed b squared, as is a times a squared times b squared. There are other options, but these are all we will list for now. Try breaking apart x to the 4th y cubed. See how many pairs of factors you can come up with. Please pause the video now. Okay, let's see what you came up with. I'm sure the first factor would be 1 times x to the 4th y cubed. The next pair of factors, x to the 4th y cubed, and then I chose to break apart x to the 4th, x squared times y cubed. Of course, there are other options. You could also break apart y cubed to be y times y squared. You could also break them up as x times x times x times x times y times y times y. There are many other options. Let's take a look at this monomial. It now has a coefficient of 18. So first I'm going to list 1 times 18x squared y. But next I'm going to break apart even the coefficient. 2 times 9 is 18, and then x squared times y would become x squared y. We could also take 3x times 6xy. I've split apart the x squared to be part of each monomial. Again, there are other options. I just wanted to give you an idea of different ways to break down monomials that include variables. Okay, so now let's talk about finding the greatest common factor, which is the largest monomial, meaning numbers and variables, sometimes just a number, sometimes just a variable, that can go into all terms of a polynomial. To find the GCF of 18 and 24, we would find it the same way as before. I could list all of the factors of 18 and 24. If I wanted to, I could do this in my calculator at the same time and compare their lists. I already have 24 in here, so let's list 18 divided by x. And then if I go to the tables, I could look for the values that they have in common. I accidentally hit graph, but here we go. So it looks like the highest value they both have in common is 6. So the GCF of 18 and 24 is 6. Now 5y and 1y don't have any numerical GCFs, but they do have a variable in common, and the highest power that they have in common is 1, so it's just 1y. If we take a look at 16x and 32x squared, both 16 and 32 are divisible by 16, so that would be the numerical GCF. But out of x and x squared, there's actually a power of x in common also. So I would state that the GCF is 16x squared. Sorry, just x. It couldn't be x squared because the first term, 16x, doesn't have 2 powers of x to take from it. So it can't have 2 powers of x in common if they don't exist. So just 16x is the greatest common factor. Now let's look at 18ab squared and 3a squared b to the 5th. This is a little more complicated, so I can expand it if I want, and then I can take a look and see, well, 18 and 3, their numerical GCF would be 3. So now let's see about a's. How many a's do they both have in common? They both have at least 1 power of a, and then I could underline 2 powers of b here and 2 powers of b there. That would make our monomial GCF 3ab squared. They both are divisible by 3, they both are divisible by a, and they both have a b squared that can be factored out. For variables, you will always choose the highest exponent that they both include. Factoring means to break apart or break down into pieces. Factoring is also described as listing the factors that multiply together to obtain an expression. So this is what we did before. We were listing the factors. But for example, when we have a binomial such as 2x squared plus 8x, we consider it factored when we express it as 2x times x plus 4, because 2x and x plus 4 are both factors that will multiply, if I distribute, to give me this product. So this is considered factored. 2x squared plus 8x is equivalent to having this monomial times this binomial. To factor using the GCF method, we use backwards distribution to factor out the GCF. So basically, we rewrite it as the product of 2 factors. These 2 factors are usually written as the GCF on the outside times the other factor on the inside of parentheses. This shows the distributive property that existed before this product was formed. So let's practice. It'll make much more sense after we try a few problems. So we are asked to factor each of the following polynomials. 15c minus 10d. So there must have been a monomial that was distributed into both of these terms previously. So to find that monomial, we have to divide or find what number divides into both 10 and 15, and that number is 5. C and D are different variables, so there is no common variable GCF. So I start out by saying, okay, 5 must have been on the outside. 5 is my GCF. Now the other factor is whatever it takes to have 5 times something turn into 15c. So to figure it out, instead of multiplying by 5, I could divide by 5 and see what would have been there before. So that would leave 3c must have been the first term, and then 2d was the second term. I can check by taking 5 times 3c, and that's 15c, and 5 times 2d is negative 10d. Okay, let's take a look at part B. 6y squared and 18. They have a common GCF of 6. Now let's see what would have been left. If this 6 wasn't here yet, 6 must have multiplied with y squared, and then 6 multiplies with 3 to give us 18. So my binomial factor here would be y squared plus 3. Let's try part C. 10ab and 5a. They are both divisible by 5, and they both contain an a. So my GCF would be 5a. And then I have to predict what was there before. So 5a must have multiplied with 2 to give me 10, but it also must have had b to turn into 10ab. And then 5a times what would become 5a? Well, 5a times 1 would remain 5a. So the binomial factor here is 2b plus 1. This expression, 10ab plus 5a, is equivalent to 5a times 2b plus 1. Okay, let's take a look at part D. 12 and 18 are both divisible by 6. They both have an x in common, and then they have actually 2 powers of y in common as well. So my GCF on the outside would be 6xy squared. Now let's predict what was there in the binomial prior to being distributed. So 6 must multiply with 2 to give us 12. We already have the x on the outside, so that would join in. And it's supposed to have 3 powers of y. There's only 2 powers on the outside, so there must have been a y here before. So 2y plus, and then 6 times 3 gives us 18. And then, oh, that's supposed to say a 3. Let's fix that a little bit. 3. And then we end up with, I already have an x and I already have a y squared. So my binomial factor is 2y plus 3. How can we check out our answers? Hopefully you were thinking you can distribute. All 4 of these can always just be distributed to check and make sure we end up with the product that we started with. Hopefully you're ready to try some of these on your own. You can pause the video for a few moments, give 1 and 2 a try. You can even check with a neighbor nearby, and then the answers will be revealed to you. So please pause the video now. Alright, the answer to problem 1 is 4 times x plus 3. 4 and 12 are both divisible by 4, but there were no variables in common. I am left with x plus 3 as the binomial factor. If I check, 4 times x would give me 4x, and 4 times 3 would give us 12. Alright, let's take a look at problem 2. 21b minus 15a. Again, there's only a numerical GCF, which was 3. 3 times 7 would give us the 21, and there must have been a b there. And then 3 times negative 5 would give us negative 15, and there must have been an a there. This time, look for numerical and variable GCFs for problems 3 and 4. Please pause the video now. Okay, so 27 and 18 are both divisible by 9, and even though the first term has 2 powers of y, the second term only has 1 power. So 9y is my GCF. 9 times 3 would give us 27, y times y would give us y squared, and then 9 times 6 gives us 18, and then that y joins in because it's really 9y times 6. Alright, problem 4. 14 and 2 are both divisible by 2, and they both have a power of c in common. So your answer is 2c times 7c plus 1. Again, that means that 14c squared plus 2c is actually equivalent to this expression, 2c times 7c plus 1. Okay, problem 5 is a little different. There are actually 2 possible answers that would both be considered using the GCF. I could divide negative 6 and negative 18 by 6, or I could also divide them by negative 6. But I also have to notice that they have an x in common. So I have two possible answers here. If I factored out negative 6, that would mean negative 6x times x will give us negative 6x squared. And then negative 6x times 3 will give us negative 18x. If I bring the negative out front, then both of these terms would become positive. However, if I didn't catch the negative, it's fine too, because 6x is another way to factor and end up with negative x and negative 3 on the inside. Please pause the video now and give number 6 a try on your own. Alright, so 4x squared y cubed and 2xy. They both can be divided by 2. They both have x's and y's in common. And because this one only has one power of each, that's all I can factor out. So 2xy is my GCF. It turns out that I end up with 2 times 2 would give us 4. X times x would give us x squared. And I only had one power of y out here, so I need 2 powers of y right here to make sure that when I multiply, when I'm distributing, I end up with y cubed. And then this last spot, make sure you did not forget the 1, because if I had nothing here, it would not be true. I still need a binomial for this to distribute and then have negative 2xy show up. So you must have that negative 1 at the end. Alright, hopefully you're getting the hang of it by now. Give problem 7 a try on your own, and then press play when you're ready to see the answer. Alright, problem 7 has a trinomial. It looks like at first glance they would have a 3x in common, but this term does not have any x's, so I cannot remove a variable. Instead, the only GCF I can factor from all three terms is a 3. So in this problem, 3 times x squared would give me 3x squared. 3 times negative 2x would give me negative 6x. And 3 times negative 10 would give me negative 30. If you're still having a hard time, as long as you can pick out your GCF, you can always try showing your work this way. You're really just dividing each term by 3 to find out what will go in here. Because 3 divided by 3 goes away and I'm left with x squared. Negative 6 divided by 3 gives me negative 2. And negative 30 divided by 3 gives me negative 10. So if that method helps, that's another way to show your work. Alright, problem 8 is another one of those problems where you could have two possible answers for your GCF. Whenever this leading coefficient is referring to the very first term's coefficient. If it's negative, a lot of times we end up factoring it out as a negative. But it's not mandatory. Sometimes on the Regents exam you'll see choices with the GCF as a negative, sometimes positive. You just need to know what's equivalent. So give it a try. Pick which GCF you want to use, and after you hit play, you'll see both answers. Alright, so the two possibilities for problem 8 are negative 4x. Out front would mean that I would have a positive x squared here, I would have a negative 2x here, and I would have a negative 3 here. Or if you chose to use a positive 4x, all of our signs inside the trinomial would be opposite. I would have negative x squared, positive 2x, and positive 3. Alright, in problem 9, do not get distracted. Build your GCF one piece at a time. First look for a number in common, then see how many g's are in common, and then see how many powers of h are in common. And then you worry about the rest. Give it a try, and then hit play to see the answer. Alright, so, turns out 3h is our GCF. Not all three terms have a g. So if I divide this one by 3h, it might help you see why g cubed is my first term that's left over. If I divide negative 9 by 3, I have negative 3 left. And this h would factor out as well, and g squared is left. If I divide 12h by 3h, I end up with just 4, because 3 goes into 12 4 times. Alright, same idea with number 10. Take it one step at a time. Build your GCF by looking for a number, then an x power, and then a y power. And then worry about the rest. Good luck. Press play when you're ready to see the answer. Okay, I've decided that 3y cubed is the greatest common factor. Y cubed is the highest power that they all have in common. Even though this term has 4 powers of y and this term has 5, only the first term has only 3 powers of y, so I must use y cubed. The last term does not have any x's, so I cannot use x in my GCF. After dividing, I see that the remaining polynomial is 2x squared plus 3xy plus 6y squared. This concludes our lesson. Now you should be able to factor a polynomial using the GCF method. You identify the GCF, and then you use backwards distribution to find the remaining terms. Thank you for watching.